Welcome to your lesson on exponential growth and decay functions. This is really a review of material for Algebra 1. So we're going to review some important terms and formulas and move kind of quickly. Keep in mind that any quantity that grows or decays by a fixed percent at a regular interval is said to have exponential growth or exponential decay. So you're looking for that fixed percent for it to be exponential. And you can think about how that differs from linear, which you're adding or subtracting the same amount each time. That's going to be linear. Where exponential, you're multiplying by a certain amount and it's growing much faster or decaying much faster. All right, here's your general equation for exponential growth. Okay, and the y here stands for the final amount. Okay, you can think of maybe bacteria that are growing. A is your starting amount. And then in parentheses, we have 1 plus, okay, because it's increasing, r. Now this r is the growth rate, okay, that percent changed to a decimal. Now be careful, this r is not the same r as we've been learning in geometric sequences, a common ratio. Okay, we're using the R kind of similarly here, but they mean totally different things. In this case, this is the percent. And then typically the exponent is our variable. And like I said, typically that represents time. So I just went ahead and used the variable t rather than x. And you're going to see all different variables used here. In business, you're going to see rather than a, you might see P standing for principal. So even though we might use different letters, they're going to mean the same thing. All right, words meaning growth, appreciation, increasing, goes up, rises, gains. All of that means exponential growth. All right, for exponential decay, our formula just changes a little bit, and here we have a 1 minus the decay rate as a decimal. So if you think about that, it's this 1 stands for 100%, and we're subtracting off the decay rate. So if I lose 20%, so 1, like 100% minus 20%, that leaves me 80%. So in that case, we are subtracting 1 minus r. Everything else is the same. Words that mean decay, depreciate, decrease, it falls, it loses, it goes down. Okay, all mean that we're going to use decay. All right, another thing I want to point out is a review from Algebra 1. Now, a lot of times when you see these equations written, you're going to see something like here where it's y equals 3 to the x power. Okay, so that has already been simplified. So you don't see this 1 plus 2 raised to the x power. They've gone ahead and simplified the 1 plus 2. And this is a rate of 200%. Okay, right there. Change to a decimal, which is 2. So what we want to do is look at this base number here once we have added. And if this number is greater than 1, so if that base number is greater than 1, we know it is increasing or growing. If this base number, okay, with the exponent, is between 0 and 1, so like right here, it's 1/2 raised to the x power. This is written wrong. It will be decreasing. So let me change that. Okay, or decaying. So you should be able to look at these equations and immediately know by looking at that base number of the exponent, is it growing or is it decaying? All right, so we're going to do 2 examples. Here's the first one. A house that costs $200,000 will appreciate in value by 3% each year. All right, so we know how the starting amount is. We know it's appreciating, which means it's going up. So that means it's going to be a growth problem. And we know the rate is 3%. So if I was to start out by saying y equals a, and if you want to put a sub 1, you can. You're kind of used to that from the sequences that we've been talking about. 1 plus r raised to, I know it says to use x over here, but let's use t because that stands for time, t. All right, so let's go ahead and substitute in the values. I have y equals 200,000, that's the starting amount. 1 plus, okay, my rate is 3%. I need to change that to a decimal. So divide by 100, which is 0.03, raised to the t power. All right, let's simplify inside the parenthesis. And I get 1.03 raised to the t power. I know I did my math correct because this number is greater than 1, and so therefore it's increasing, which is what we're expecting. All right, find the value of the house at the end of 10 years. So that means t is equal to 10. So you're going to take 10 and you're going to substitute it in here. So in your calculator, you're going to type 200,000 parenthesis 1.03 raised to the 10th power. All right, so after 10 years, okay, that house is now worth $268,000, 783. I'm just going to kind of round it there to the nearest dollar. And let's add our dollar sign so that we know that what unit we're talking about. All right, let's look at another problem here. Ian's new Mercedes cost him $75,000. From the moment he drives it off the lot, it will depreciate by 14.2% each year for the first 5 years. How much is the car worth after 5 years? Okay, so looking at this problem, it's depreciating, so it's going down. So this is a decay problem. I have the percent, I have the starting amount, and that's what I need to know. And I also have the time here for 5 years. So let's start by writing the decay formula here. 1 minus r raised to the t power. Let's go ahead and substitute in. Our starting amount is $75,000. I'm going to switch colors here. 1 minus. Okay, so 14.2%. Divide that by 100. I get 0.142 raised to the time, the t power, which is 5 years. All right, I'm going to rewrite that as 75,000. I'm going to do the math inside the parentheses. That gives me 0.858 raised to the 5th power. And at this point, I can put it in my calculator. All right, so after 5 years, how much is this Mercedes worth? It is worth $34,870, I'm going to round it, $74. Now you may be wondering why I did this step right here where I went ahead and simplified what was inside parentheses. And I want you to get in the habit of doing that, because if you stop right here and put this in the calculator, you're not going to get a sense for this base number. And that base number is going to be really important as we continue to talk about exponential functions. We start changing this rate up here. This is over 5 years. What if I want to change it to months? And so this number is going to be really important that we've gone ahead and simplified it. So if you will, get in the habit of simplifying this before you put it in your calculator. All right, so here's your review from Algebra 1, how to write an exponential model. First of all, decide if the model is growth or decay. Most of the time, these are going to be word problems. And so you're going to have to decide, is it growth or decay? You need to look for your starting amount or your starting value. And then you need to find the rate that we're calling this R. and then you simply substitute it into the correct formula.